In the eternal twilight of the North Atlantic and Arctic depths, where the temperature hovers at the brink of freezing and the pressure is immense, dwells a creature that defies the human concept of time. The Greenland shark, or Samniosus microcephalus, is a biological anomaly that challenges our understanding of aging and vitality. While most vertebrate life measures its existence in decades, this shark measures its life in centuries, drifting through the deep like a silent, living relic of the past. To look at a Greenland shark is to look at a witness to history. There are individuals swimming today that may have been born before the Great Fire of London or the arrival of the Mayflower on American shores. The secret to this incredible longevity remained a mystery until relatively recently, because these sharks lack the hard, calcified structures like ear bones or vertebrae rings that scientists usually use to determine age. Their true lifespan was a matter of speculation. It wasn't until a team of researchers applied radiocarbon dating to the lenses of the shark's eyes that the staggering truth emerged. The proteins in the center of their eyes are formed during gestation and remain unchanged throughout their lives, acting as a chemical time capsule. The results of these studies suggested that these sharks can live for at least 272 years, with the oldest specimens likely exceeding 400. Perhaps most shocking is that they do not even reach physical maturity until they are roughly 150 years old, spending over a century in a state of biological adolescence. This profound longevity is fueled by a life lived in extreme slow motion. In the frigid waters of the high north, every metabolic process is dialed down to its lowest possible setting. The Greenland shark is a personification of slow and steady. It moves at a cruising speed of about 1 mile per hour, a pace so leisurely that it has earned the nickname the sleepy shark. Its heart beats only a few times per minute, and its tissues grow by a mere centimeter each year. This sluggish metabolism is an evolutionary masterstroke. By burning energy at such a glacial rate, the shark minimizes the cellular wear and tear and oxidative stress that lead to aging and disease in other species. It is a master of conservation, thriving in a world where food is scarce and the cold is unforgiving. Despite its slow-moving nature, the Greenland shark is a formidable apex predator. Its diet is a curious mix of the slow and the swift, containing everything from bottom-dwelling fish to seals, and even the occasional remains of land animals like reindeer. Scientists believe they are expert ambush predators, perhaps scavenging or striking at sleeping seals that float in the water column. This predatory life is often complicated by a unique parasite, a small crustacean that attaches itself to the shark's eyes. These parasites eventually render the shark partially blind, yet the animal's other senses, smell and electroreception, are so finely tuned that it continues to hunt and thrive in the darkness of the abyss, seemingly unbothered by its lack of clear sight. The cultural footprint of the Greenland shark is as strange as its biology. In Iceland, the shark is the source of the traditional dish known as a carl. In its raw state, the meat is toxic to humans due to high concentrations of urea and trimethylamine oxide, which act as a natural antifreeze in the shark's blood. To make it edible, the meat must undergo a grueling process of fermentation and air drying for months to neutralize the toxins. This interaction highlights the shark's unique chemical makeup, a cocktail of biological compounds that allow it to survive in temperatures that would freeze the blood of most other creatures. Today, the Greenland shark stands at a crossroads of scientific fascination and environmental vulnerability. Their slow life cycle makes them incredibly susceptible to overfishing and habitat disruption. A population that takes a century and a half to reproduce cannot easily bounce back from human interference. As we map their genome, we are finding clues to cancer resistance and heart health that could one day revolutionize human medicine. They're more than just old fish. They are biological blueprints for survival against the odds. As they continue their 4-century-long journey through the dark, cold corners of the world, they serve as a humbling reminder that on this planet, some of the greatest wonders are those that take their time. Would you like me to focus on the specific genetic adaptations of the Greenland shark, or perhaps explore the conservation efforts currently in place to protect them?